Hello there and welcome to my video on logarithms, the second part in the series where we're going to be going over equalities in logarithms, or as most of you know, some of the definitions of logs or the properties of logs, just items that you can use to help you solve logarithmic expressions. So a couple of things that we have to know is in the last video I went really in depth into properties of exponentials and how to start converting back and forth in between exponentials to logarithms. Well, another side of it that you do have to know is how to go between the multiplication involving bases and the division involving bases. Now, as you notice, both of these look like formulas, and for those of you who don't like memorizing formulas, there are certain things that you can keep in mind to help you get through this more effectively. If you're multiplying with the same base, you're really adding the exponents. Whereas opposed to if you're dividing by the same base, you're really subtracting the exponents. Nothing 100% to worry about, but this is just something to keep in mind because exponentials and logarithms go hand in hand together. So, if I give you an x to the n plus m equals y, and we used our conversion factor from the last video, well then we get log of some xy equals n plus m. Okay, no biggie. But that also means if we do subtraction and we use the same conversion factor, well then we're going to get something very similar just with a minus sign. Okay, so what does that lead us to in the long run? What if we're dealing with, in this case, a log with addition inside of it? Well, there's nothing really too much to concern yourself with. It's just going to convert itself back using an exponential, and then you have essentially your answer. So is there anything special with addition in logarithms? Not really. Well, but what if we were going to deal with a logarithm that had multiplication inside of it? Now keep in mind this section is going to be a little bit longer, and if we try to convert it out to an exponential, this looks okay, but let's just say for the moment that a and b are just two different numbers. So a is a number and b is a number. They don't have to be the same number. They can also be variables, but we're not going to mix you too much up in variables in this case. But let's see here. Well, if I said that this y value is the sum of two numbers, well, then that means a has to be x raised to some power and b has to be x raised to some power. Okay, that works out for us in the long run. So if we do some substitution, we get x raised to some power times x raised to another power equals x to the y, using an exponential equality. Oh. And again, if this doesn't make a whole lot of sense to you, don't worry about it quite yet. This is going to simplify itself out to if you're multiplying within a logarithm, then you are going to separate it in terms of addition. Because if you remember in the last video, a logarithm spits out an exponent value. Just like this logarithm is also going to spit out an exponent value. Which means that if we are multiplying within a logarithm, we are going to separate them by addition. Okay? So this whole section right in the middle is a short little equality that you can use to remember if you're a math whiz, or if you just want to know it for the sake of knowing it. But other people just want to go straight from part A down to part B. And again, nothing wrong with that, but keep in mind how much this affects your ability to solve logarithms. And do I honestly recommend that you memorize the entire equality? Well, in all personability, No. But I do recommend that you know that if you are multiplying within a logarithm, then the output is 2 logs being added together. That I do recommend that you know. But do you need to do the proof of equality each time to solve a logarithmic equation? No. No, 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 no. Not unless you plan on going up into higher ends of calculus. And you can do the same thing for division as well, but we're going to stick primarily to the multiplication aspect. So in multiplication, you are adding, and in division, you are subtracting, just like with an exponential function. So wait a minute here. Let's slow down a second and catch up to ourselves. In an earlier video, we said x to the n plus x to the m meant very little to us, okay? But x to the n times x to the m is the same as x to the n plus m. Brilliant! So when you're multiplying within a logarithm, you're adding 2 different logarithms. And the same thing over here with division, you're really subtracting. With me so far? Now, one property of exponentials that I didn't go into is that if you are raising something within the log to a power, then this power drops out to the front, and you just multiply that by whatever the log value is. So let's do an example. Log of 2, 4 squared. Let's see, that's the same as log of 2, 16. So 2 to what power equals 16? Let's see, 2, 4, 8, 16. That would be 4. Well, what if I wanted to simplify this for myself? What if I said log of 2, 4 squared equals 2 times log of 2, 4? Well, that's just the same as 2 times 2, which is also 4. Oh, and we'll go over a couple more practices with these. Don't worry about that. We'll make sure that you have a firm understanding. But as far as everything is concerned, the rules of logarithms incorporate these 3 ideals: multiplication, division, and exponents. With me so far? Good. So as far as this video is concerned, we're relatively finished with this, and more importantly, multiplication, addition, division, subtraction, exponentiation, multiplication. See y'all next time.